When copper, it is this color, reddish pink. When it undergoes oxidation with the copper sulfuric acid, it will form copper sulfate. What you can see the color? It will be in the solution form. Now I'm just showing you the solid. It's a blue color. So pink, reddish pink to blue color. That also can be your observation. Hi, hello, namaskara children. Welcome back to the Chemistry channel. My name is Mahantesh Shettar. So today we are going to learn about very important chemical. What is that? Sulfuric acid. This is a very common acid. I think everyone knows. Okay. But here I'm not going to tell you about the manufacturing process and all. I'm directly telling you about the chemical reactions of sulfuric acid. It's a very interesting story, you know. What happens here? Before that, sulfuric acid is known as king of chemicals, not queen. King of chemicals. Okay, don't ask me which one is called as queen of chemicals. Why king of chemicals? Because in most of the chemical processes, in most of the chemical industries, pharmaceutical industries, we use sulfuric acid. So because of that, it is also known as oil. Oil? Yes, oil of vitriol. So what is this new thing? It's not a new thing. You might have already know about the term vitriol. Let me give you blue vitriol, right, and green vitriol. These are all vitriol, common names. Blue vitriol is copper sulfate, pentahydrate. Green vitriol is ferrous sulfate, heptahydrate. Okay, so you can see sulfate is common. Initially, so many years back, sulfuric acid was extracted or prepared by, prepared by using the green vitriol. So it was in the form of oil, so they called it as oil of vitriol. Why are they called that? Oil of vitriol. Okay, sir. Next, I will take the chemical reactions of sulfuric acid. Before that, you should know there are two forms of sulfuric acid. Yes, what are those? Dilute H2SO4, concentrated conc H2SO4. So dil mangi more, yes, but it is dilute, short form dil. Concentrated, short form concentration. What do you mean by dilute and concentrated? First you understand that. Okay, dilute means less amount of solute in more amount of solvent. These are all what solutions, na? Dilute sulfuric acid, aqueous solutions, means you are dissolving it in water. Okay, what do you mean by concentrated? More solute in less solvent. Okay, sometimes these are also used as relative terms also. Say there is a 50% solution of sulfuric acid, 60% solution of sulfuric acid. So 60% is more concentrated compared to 50%. So this is called as relative terms. Okay, anyway, now don't ask me, you don't know what is solute, what is solvent and all. Okay, let's say you don't know what is solute and solvent, what is solution. I will give you a simple example. Solute is, say you want to prepare sugar solution, you want to prepare sharbat. Okay, you will take the water you need, na? So you will add sugar and dissolve it initially. Later on you will add some nimbu, gimbu, etc. Okay, but initially water and sugar is the solute, water is the solvent. So you are taking a little amount of sugar, more amount of water, that is dilute. Dilute sharbat, more amount of sugar, less amount of water, that is concentrated sharbat. Okay, clear? Dilute and concentrated. Now sir, why you are telling this in 10th grade? Because there is a reason. Dilute sulfuric acid, concentrated sulfuric acid, difference you have to understand. Now I will ask you a question. Out of these two, which is a very good acid? Which is a very good acid out of these two? Many people may tell the wrong answer. They may pick this one, but that is not correct. So the good acid is dilute. Sir, why? Why? Because you know the acid definition. It should give us H plus ion when dissolved in water, or H plus will combine with water and you will get hydronium ion. So dilute means there is water, there is sulfuric acid, more amount of, and sulfuric acid is a very strong electrolyte. Strong acid means it completely dissociates into ions. So you will get more number of H3O plus ions in case of dilute sulfuric acid. Concentrated, what happens? Only less amount of water is there. So sulfuric acid, hydrogen sulfate will not decompose, will not dissociate, and will not form the ions. Okay, so therefore it is a weak acid. If they ask you concentrated sulfuric acid is strong acid or weak acid? Weak acid. Strong acid is dilute sulfuric acid. Okay, fine. So now then both do not have same properties now. Okay, so here this acts as a pure acid, purely as an acid, but concentrated sulfuric acid has different roles, I can say, different things. It has different ways to react with different substances. First we'll see this part, then we'll go to this part. Okay, so write down the heading: chemical properties of dilute sulfuric acid. Dilute sulfuric acid. Okay, so as we already know, it is acting as an acid. So you can write the reaction of typical acids. What is those reactions? Remember these reactions. It is applicable to all mineral acids like HCl and HNO3 also. There are some exceptions in HNO3. Otherwise it is applicable. So let's see. Acid, this general reaction I'm giving you, acid with let's say any metal carbonates or bicarbonates. By now you should know all these things. Okay, if you don't know, you have to go back to 9th grade and learn them again. Okay, carbonates and bicarbonates, metal carbonate and bicarbonate react with acid, whatever acid it is, mineral acid. You will get salt, water, and what? CO2 gas. Very important. Many observation based questions, balancing equation questions, these reactions will be there. What is the observation here? Colorless gas turns lime water milky, has no effect on acidified KMnO4, because SO2 also shows same thing. Okay, this is one. Second one, acid plus sulfite. Okay, carbonate, if you don't know, it is CO3 minus 2, bicarbonate is HCO3 minus. Sulfite or bisulfite. Sulfite is similar to bicarbonate. Instead of C, you just write S. SO3 minus 2, HSO3 minus. That's it. So you can also replace it here. You will get same product, salt and water. And instead of CO2, what you will get? SO2. So you have to write now, this is also colorless gas which turns lime water milky, but it also has effect on acidified KMnO4. It turns it from pink to colorless. Acidified potassium permanganate will be turned from orange to green by SO2, but these two reactions will not shown by CO2. Okay. Next reaction, acid plus metal. This one you already know. Okay, active metals. Okay, which are above hydrogen series in the above hydrogen in the reactivity series. So what you will get, respective metal salt, whatever acid it has okay, metal sulfate, metal chloride, metal nitrate, okay, metal salt plus hydrogen gas will be released. What is the test for hydrogen? It is also colorless, odorless, neutral. Pop test. Burns with a pop test, pop sound. Okay, what else? Carbonate done, sulfide done, metal done. What else? There is one more, I'm forgetting. Acid plus sulfide, metal sulfides. Okay, very important, metal sulfides. All are metal carbonate, metal sulfide. See the difference, De here, De. So you will get a salt, respective metal salt plus H2S gas. H2S, you know, nice fragrance. What is that nice fragrance? Rotten egg smell. Nobody wants to smell it. Okay, rotten egg smell. The gas with rotten egg smell released. That is your observation here. Okay, so these are the general equations. You can write this for dilute sulfuric acid, dilute HCl, hydrochloric acid, okay, and even dilute nitric acid. Don't write for concentrated. Dilute nitric acid, exception is this, because here when dilute nitric acid reacts with metal, you don't get hydrogen, you will get water. As it's a very strong oxidizing agent, it oxidizes hydrogen to water. Okay, so these are all general reactions. Can I give you one example for all of these using dilute sulfuric acid? Okay, can you do the remaining things for yourself? You can try with different metals. So what we are taking here, H2SO4 dilute. It is very important, you have to mention from now onwards what sulfuric acid you are using, dilute or concentrated. Now carbonate, I will take sodium carbonate, Na2CO3. You can also take sodium bicarbonate. So what will happen? NaSO4. So Na2SO4, this is the salt, plus water, H2O, plus CO2 will form. Okay, not going to balance this. Anyway, you know how to balance. Again sulfuric acid, dilute. So take sodium sulfite, Na2SO3. Just write Na2SO4 sodium sulfate, sorry, water, and SO2 gas is released. Next, take dilute sulfuric acid plus metal. I will take the magnesium, so magnesium sulfate will form, plus hydrogen. Okay, next take sulfuric acid, dilute, plus what is that? Sulfide. Say I will take ferrous sulfide. Okay, H2S you remove from this, so FeSO4 plus H2S. So these are the reactions. Okay, hope you wrote these things. So these are all about dilute sulfuric acid. Let's go to concentrated. Very interesting. Concentrated sulfuric acid. Now concentrated sulfuric acid will, I already told you, it's a weak acid. So what are the properties of this? What it can act as? What are the roles? So basically it's a non-volatile acid. So what is non-volatile? Volatile means which can evaporate. So you take hydrochloric acid and HNO3, concentrated form, some vapor, some fumes will keep on coming on out of the bottle. If you keep it open, you can observe it. So these are called volatile acids. These are volatile acids. But sulfuric acid is not like that. It will not form any fumes unless it is fuming sulfuric acid, which you call it as oleum. That is different case. Okay, so it's simply non-volatile acid. Okay, what it can act as? It can act as an oxidizing agent. Very important. Oxidizing agent means which oxidizes other substances. Itself it will get reduced, right? Oxidation reduction. Next, what else it can act as? It can act as a dehydrating agent. Dehydrating agent, drying agent. Drying agent is simply absorbing the moisture. Say in preparation of HCl, you pass HCl through constant sulfuric acid solution. It is absorbing. It is a drying agent. Dehydrating, difference between drying and dehydrating. Dehydrating will take out the water molecule or the elements forming water molecule. What are the elements forming water molecule? H and O from the compound will come as H2O. So that case you call it as dehydrating agent. It is a chemical reaction. That will be simply absorption. Drying is simply absorption. Okay. Non-volatile nature, where we use it. These are the very important points. Many questions are asked on this. Okay, so this is used in the preparation of this nature, preparation of HCl and HNO3. Okay, if you haven't seen, you can check preparation, laboratory preparation of HCl. I will give you the link here, the corner, left hand corner. Okay, HNO3, HCl, they have similar methods of preparation, laboratory preparation. What we take, their salts. For HCl, we'll take NaCl, we add concentrated sulfuric acid below 200 degrees Celsius, NaHSO4 plus HCl. Similarly, just take NaNO3 plus conc H2SO4 below 200, NaHSO4 plus HNO3. These are the gases released. What happens, sir? Above 200 degrees Celsius, it will form sodium sulfate. Sodium sulfate is difficult to remove because it will form a hard crust inside the RB flask. So therefore, we don't use above 200 degrees Celsius. Done. So what is the use of non-volatile nature? Preparation of HCl and HNO3. Done. Okay. Now come to this part. Okay, oxidizing agent. As I already told, it will oxidize other substances. Now I will show you something very interesting. Here you have to worry about only 3 elements: carbon, sulfur, copper. Carbon, sulfur, copper. Okay, how they react with concentrated sulfuric acid. Okay, copper will not react with dilute sulfuric acid because copper is below hydrogen reactivity series. Dilute sulfuric acid is acid, so it cannot displace hydrogen there. But here copper can be oxidized by concentrated sulfuric acid, so you can see the difference, right? Okay, carbon many of you might have seen, but still I will show you. So you can see this is the carbon. I asked my mom to make this. This is a kajal. Kajal is one of the forms of carbon. Carbons have many different forms. So okay, you can see this. Next, sulfur. If you haven't seen sulfur, this is the sulfur. Okay, sulfur is the yellow solid. It's the yellow solid. Okay. Copper. If you haven't seen copper turnings, so you can see this is the copper turnings. Okay, reddish pink metal. So when these react with concentrated sulfuric acid, what you will get? I will give you simple technique to remember, because many times these will be asked for balancing equations. Okay, this one I will wipe. Shall I wipe this? Okay, the editing will come later. Now I will take, remember, how do I remember? Sulfuric acid concentrated, hydrogen will give you water, SO4 I will divide into SO2 and O2. What is oxidation? Addition of oxygen. So if it is acting as oxidizing agent, it should lose oxygen, so leave this. So it itself will undergo reduction. So always whenever concentrated sulfuric acid acting as oxidizing agent, the reduced products right side, you will always write H2O and SO2. Okay, say for example carbon plus sulfuric acid concentrated. Carbon will take what? oxygen because it is oxidizing agent. So it will become what? Carbon dioxide. What happens to sulfuric acid? It should get reduced. What are the products? H2O and SO2. H2O and SO2. Okay. Now sulfur, same thing. Sulfuric acid concentrated. Don't forget to write concentrated dilute. Okay. It will oxidize to SO2 plus what are the other two products? H2O and SO2. SO2 already written. So just write H2O. This you have to balance. I'm not writing the balanced equation. You have to balance this. Copper plus H2SO4 concentrated. Copper will drink H2SO4 and form copper sulfate plus H2O plus SO2. Right? So this is the technique you have to remember because many of the questions are asked on balancing equations like this. So how this is oxidation? Very simple. See, copper in the elemental state has no valency. Okay, I mean, yeah, 0. Here, ionic state plus 2. So when copper loses 2 electrons, it is forming copper plus 2. Loss of electron is what? Oil rig. Oxidation is loss of electron, reduction is gain of electron. So it is undergoing oxidation. Understood? Understood the point? Okay. So to balance this, I will not write everything balanced equation. I will just tell you for all of these you need 2 H2SO4 molecules. Remember 2. Here you have to write 2, 2, 2. Right side you can balance now. Okay. Right side you can balance. And always 1 H2SO4 will give you 1 H2O and 1 SO2. 2 H2SO4 will give you what? 2 H2O and 2 SO2. So straight away I will write here 2 H2O, 2 SO2. Here what's the difference? Because one extra sulfur is coming here. So 2 plus 1, 3 SO2, 2 H2O. H2 will not change. Here again 2 H2O will be same, but sulfur splitting as SO4 and SO2. So there you should be careful. So 2, so no, nothing here on simply SO2. Yes, is this balance? Copper, copper, 4 hydrogens, sulfur 2, oxygen 8, 4 plus 5, 6, 7, 8. See, so simple technique to balance these kind of equations. What you have to remember, you always need 2 H2SO4 molecule when it is acting as an oxidizing agent. It always give one molecule, give 1 H2 and 1 SO2. So 2 will give 2. But you have to check these things. Done? Okay, shall we go to the next thing? Okay, sir. Observation, what you will write? You can write for SO2. But here you can write for copper. Copper, I forgot to show you. When copper, it is this color, reddish pink. When it undergoes oxidation with the copper sulfuric acid, it will form copper sulfate. What you can see the color? It will be in the solution form. Now I'm just showing you the solid. It's a blue color. So pink, reddish pink to blue color. That also can be your observation. Right? Okay. Now, last point. What is the last point? Dehydrating agent. Dehydrating agent. Okay, as I already told you what is dehydrating agent. Done. Now here you have to worry about my son. Blue vitriol, copper sulfate, pentahydrate. So again, what is the color? Blue vitriol, same thing, copper sulfate. This is decahydrate, but anyway, if it is hydrated form, it will become blue. If you remove all the water molecules, how you remove? You add concentrated sulfuric acid. It will take away all the water molecules. What is left? Copper sulfate plus 5H2O. Very simple. What is the observation? This is blue in color. This is white in color. So you can write this is crystalline substance. This is amorphous substance. So what is crystalline amorphous? Crystalline means the particles in the molecule are arranged in a definite geometry. You might have observed crystal of sugar. Okay. Amorphous means like a powder, whatever you apply on the face. It has no different geometry. The particles are arranged however they want. ठीक. This is one point you have to think. Next point. So what happens if you take the sugar and add the concentrated sulfuric acid? I forgot to show you. This is the dilute sulfuric acid. Dilute means, as I already told you, more amount of water, less amount of solute. Concentrated also look like this only, but you know, by color you can't change. It's all colorless. Okay. Sugar may be normal sugar what you use, or it may be cane sugar. Okay. When it reacts with concentrated sulfuric acid, what happens? Very interesting experiment is there. You can go to the YouTube and type sugar with concentrated sulfuric acid experiment. You will observe very nice experiment. Black snake of carbon will form. Okay, it will come like this out of the test tube. Okay, so sugar formula C12H22O11 plus concentrated sulfuric acid. So what is acting as? It is acting as the dehydrating. What are the water molecules? H and O. It is there. I will just write it for our understanding like this. H2O 11. Same thing, na? So it will absorb all 11 water molecules. What is left? Carbon. 12C plus 11 H2O. So this is observation for carbon. Black, spongy mass of carbon rises up. Why it rises up? It's highly exothermic. All the water will evaporate. Only you will left with carbon. This carbon is a very pure carbon. Okay, just it's a totally carbon. It will rise up. So I have put this image in one of my observation based questions. I have made a video. You can see it here. Okay, so there you can see all of these observations pictures I included. Okay, so this is for sugar. Same thing happens with simply glucose. If you take glucose C6H12O6, this is a simple sugar they call it. Same thing, concentrated sulfuric acid. Again there are 6 water molecules, so 6 carbon plus 6 H2O. Okay, so this is with glucose. Again what is formed? Carbon. Okay, if you remember organic chemistry concept, in that, in the preparation of ethene from ethanol, ethene from ethanol, ethanol is CH3CH2. I will just write it H here, OH here, CH3CH2OH. So we add concentrated sulfuric acid. So what happens? This water molecule will be absorbed by concentrated sulfuric acid. A new bond will form between carbon and carbon. So you will get to CH2 double bond CH2 plus H2O. What did you call this as? Dehydration of alcohol, or particularly for ethene it is dehydration of ethanol. So what property of concentrated sulfuric acid used here? Dehydrating property, dehydrating agent. Okay, so these are all the important chemical reactions of the concentrated sulfuric acid and dilute sulfuric acid. Okay, so we'll take up other compounds as well and see how to remember the important reactions. So we'll meet in the next class. Until then, take care. Bye bye.